Hello and welcome back to another video. Today we're going to be talking about the quadratic formula. Okay, so first of all, we got our first example here, which is 2x minus 5, or 2x squared minus 5x plus 3 equals y. That's you know what? I'm not sure. I think it should be y. Could be wrong. Yeah, no, that's y. Okay, first of all, we gotta find our A, B, and C values. So we're gonna plug in, we got 2 as our A value, we got -5 for our B value, 3 for our C value. Then what we're gonna do is we're gonna plug it into the quadratic formula. So we're gonna take our -b, -5, plus or minus square root of -5 squared minus 4 times 2 times 3. Divide that all over by 2 times 2. And then we're going to simplify that. So we're going to take 8 times 3, or -8 times 3. And 25 square roots. This 5 is going to become positive for 4. 8 of 24. 5. 1. Square root of 1 is 1, so we're going to have 5 plus 1 divided by 4, which is 6 over 4, or 3 over 2. And then we're going to have 5 minus 1 over 4, and that's going to be equal to 4 over 4, which is equal to 1. Those are our two x values. And that's going to be the quadratic formula. Next, we're going to be doing factoring, which is another type of the quadratic equation that we're going to use. So we have, the best way to do this is to figure out the two values that add up to this value in the middle that multiply to this value on the right. So in this case, 2 and 4 seem like they're the best bet, because 2 times 4 is equal to 8, but 2 plus 4 is equal to 6. And then we'll take that and then split it into the factors. And then our value is going to be -2 and x equals -4. A common mistake could be that you use 2 or 4, but how that really works is you take your x plus 2, you set it to 0, you minus an x on each, or actually it'd be better to subtract 2, so then you set -2 equal to x, and that's how you would find those values if you're curious. Some of the real use cases of it would be to find the area of isosceles triangles. You can use it to predict revenue. You can use it to calculate projectile motion in physics by creating arches. It's also good for curved equipment in 3D modeling, typically used for auto body design and for modeling the shape of bridges. The kind of arch, or the little rope things that hold suspension bridges together. I can't remember what they're called again. But they use that to calculate how much weight it can safely support. I think that's it. Cool.